In today's episode of Monsters, we are going to be doing projectiles. So Mo is going to be throwing stuff at us, hoping to take our heads off. Let's get started. I'll go game object and then I will make a sphere. I'll call that projectile. Make that a child of Mo. And let's start setting some of these values. So I set that to 0, 0, 0, I can kind of see it. And that's going to be the projectile that Mo throws. Now it's way too big right now, so let's just bring that down. Take it up in the middle and scale it down. Okay. That looks better. And I'm just going to bring that just to Mo's palm. The next thing to do is get a particle effect for this projectile. So I'm going to head over to the 52 special effect pack and let's look for a reasonable particle effect. I'm going to use Iceball. Fortunately I don't get the preview, but I'm going to hope that this one looks the way I want it to. So let's bring that down here and let's zero, everything's zeroed out. Okay, so now when I play that, I should see like an Iceball effect. Yes, okay. That might need some refinement, but as a base, that's okay. Now, let's get this actually behaving as a projectile. Another IEnumerator method. And we'll call this throw projectile. Before I can implement this, I'm going to need some references, aren't I, to the various bits and bobs we've just added to Mo. So let's set some of these things up. Let's think about what we want. Lake float, and we'll call this distance for projectile throw, and we'll set this to the further back, so let's say 10, and then we can pretty much mimic these control variables that we had for the stomp effect. So let's say float and then time between projectile throws. I'm going to set that to 5 as well. And let's say the damage for projectile. Let's set that to 30. Okay, and this will also need an offset because the actual projectile does not leave as soon as the throwing motion begins. It's kind of halfway through the throwing motion. If you think about a ball leaving your hand, it leaves when your motion is kind of halfway through, you winding your hand back and your hand following through after the throw. So let's have a offset for this as well, and we'll call this projectile throw animation and time offset, and let's set that to 2 for the time being, and then we can refine that as and when we need to. Let's get the game object that represents that sphere that we just made. So we'll go game object, I'll call that projectile. And then we also need to add a rigid body for the physics, for the actual throwing part of that projectile. So we'll say projectile RB. And so since we've added that, we need to actually add it to the projectile. So we'll go add component and we'll say a rigid body. And as well as having a rigid body, it's going to need a collider. I'll make a sphere collider for this. Okay, and that's for when we actually hit the player. So we'll say projectile equals transform dot find, and we'll give it the name, which was projectile. One is the game object. For that, to get the RB, the rigid body, we can say projectile get component, and we'll say rigid body. First thing I'm going to do is start my boss animator, and we'll say set trigger to the thing that did the throw. I think it was called throw. So that's my motion started in exactly the same way I did for my shockwave. I'm gonna wait for a few seconds. Say wait for seconds, and that was held in my parameter. Excuse me, that was held in my variable, which was called throw offset. So what a great name that is. I'm going to make this a float just so we have some control over this. We'll say to F. So we have final control over that. We need to set the kinematic flag to false because we're about to apply some physics to this projectile or to the rigid body. Then we need, in order for this to fly towards the player, we need to break the relationship between the projectile and the parent, so it can actually leave because at the moment it's a child of the parent, so anywhere Mo goes, the projectile goes, but obviously once you've thrown the projectile, you don't want Mo to follow, so it has to break that parent-child relationship. And the next thing is to make sure that the projectile goes towards the player. So we'll say look at the player, so that's gonna make sure that it fires towards the player. And then we will add some actual force. So we'll say projectile B and add force. And we want to move this by saying projectile RB not transform, and then we want to move in the forward direction, and then we'll give it some multiplier for the distance. So to summarize, the kinematic means we're going to allow the physics to take over, and we'll see why we need this in a second. Then we break the parent-child relationship, and then we actually throw the thing. We need to actually handle the state for throw because we're not doing that right now. So we've got one for stomp. So we'll simply say else if distance to the player is less than distance for the projectile throw, then very similar, we are going to transition into the throwing state. So we'll say state throw, and we will write that case. We'll write that part of the state machine. So we'll say case state throw. What do we need to do here? Let's think about this. First thing, let's set the countdown timer, and we'll say time between projectile throws. Okay, I'm going to write a little method called reset projectile just so we can encapsulate this bit of functionality. Oops. Reset projectile And this is because once it's been thrown once, it has to go back to its original position. And so we'll say, and this is what this reset method is going to do. It's going to bring everything back to its initial point, so we can reuse the exact same game object every time. So the first thing to do is we'll recreate that parent-child relationship, and so we'll simply say the transform is going to be that. And then initially, so before the projectile leaves our hand, it has to be controlled via the script. So therefore the kinematic part has to be true, and then we need to actually reset the position. So we're going to say projectile dot transform. So we're going to move it back underneath the hand of Mo. So we'll say local position equals new vector 3. Okay, and for this I'm going to store the origin of the projectile. So I'm going to make my variable here. So I'll say vector 3 projectile origin, and that is essentially going to track. It's going to track this position here. Let me put this into a slightly different layout. Okay, it's going to track this position, so this offset against the sphere's parent, which is Mo. So essentially it needs to come back to this value here, regardless of where I move it. When I want to reinitiate a projectile, it has to come back to this initial position. So that's the position I need to store in that vector, and I'm going to do that in my start routine. So projectile origin will equal projectile dot transform dot local position. Yeah, I should set that. We'll say new vector 3. We'll set it to that. Can we set it to that? No. Okay, we'll do it the other way. We'll go X, Y, and Z. That should give, and so that means when we want to reset, we can simply go X. I don't like the fact that I'm making a brand new, I'm allocating new memory here, but I'm going to leave that for now and then fix that later. So that will reset everything back to its original point, because over here, remember, we break the parent-child relationship and then we move to a brand new position. So reset simply recreates that relationship and moves it back to be underneath Mo's hand where it started. So let's just call that. So we'll say reset projectile goes there, and then we want to actually call our throw projectile method. So we'll say start coroutine inside. Oops, I forgot my break statement. It's not good. Okay, so that should get rid of that error message. And then from here, okay, now that we've initiated that throw, we're going to go into state waiting, because we need to wait for that to complete before the whole thing happens again. Let's see what we have. Okay, so you have the particle system playing, but it doesn't play for very long and then it kind of stops. That issue with the Iceball kind of fading away, it's got nothing to do with the particle system. It's actually this little chiplet here, the CS particle move script. So it's actually moving on its own. So when I disable that, now, boom, whoosh, there you go. All right, still got some clearing up to do to get this particle system looking more like a projectile, like a fireball, and we're just going to start working on these one by one. So let's take that core. First of all, it's huge, it's way too big. So I have been having a look at this, and if I go into shape and then I get this little curve, I can just bring that down. That looks much more reasonable. I don't actually want to see the sphere. In fact, I don't want to see the sphere at all, do I? No. So let's disable the mesh renderer. Okay, it will still be there, as in it will still have the effects, but I just don't need to see the sphere. So now if we bring in this one here, that one has the exact same problem, core 2. What I'm trying to do is get that diameter of core 2 to come down. Parameter I believe I want is this radius here on the shape. So if I start bringing that radius down, you can see you get a much more concentrated effect. If it's too far away right now, so I'll bring that sphere back. And if I bring this in, because this arm actually starts from around about there, down to the right. Now let's see. Yeah. Cool. Bring the mass. I think it's too light right now, so let's give this a bit more mass. Yeah, it's too fast. Okay, one more time without the renderer. Let's see what that looks like. Yeah, I think that looks... The problem before was that it was moving way too fast. Let's detect the collisions that are occurring when the ice ball is thrown. Pass the collision message up the chain, up to mode. There's a couple of ways you can do this, but I'm going to do it this way. So I'll just say projectile script collision, and let's write the on collision enter. Make a reference then to the Boss AI script. And we'll say Boss AI. That was public Boss AI. And we'll go Boss AI script. We'll say void tile. And this should, public would help. This should then be able to call the projectile collision, and that's all this script needs to do. It's just going to pass on that event up to the Boss AI, and the Boss AI can take it from there. So we'll check if we've hit the player. And if we have hit the player, we can say player script dot hit, and then some damage for projectile, and that should take care of inflicting damage from this action. Let's give that a bash and see what we have. I'll set that script to be the one from Mo. Okay, let's give that a go. And this time, boom, there you go, you see the damage being done. Ouch. To complete the sounds, we're going to have to modify this part. At the moment, the audio clip is hard coded to be the audio clip for the stomp, and I want this to be selectable depending on whether it's a stomp or a projectile. Audio clip, some sound effects. The audio clip we've selected, so we'll say clip equals stomp sound effects, and that takes care of that. And these have got to be public because they can be set, so they can be set in the inspector. Public there and public there, and then we grab these two guys, we plop them over here where all our other public variables are, and then we'll just make it again. I don't like copying and pasting logic at all, but I'm going to do that this time. So we'll say play projectile. Oh yeah, this could just be done with the parameter to the function, but hey, there. Okay. Now we can complete the collision. So we send some hits, and then we'll play some sound effects, and we can give that a test. Now the one for the stomp was blow, and then I can set this, and I should get 2 sound effects playing. Mo's got some pretty neat tricks up his sleeve. Throw some projectiles. Okay, that's oof. And if you get too close, not gonna like that either. Boom. I have 1 bug left to fix. If you watch the health, it goes to 40% because the projectile's damage has been set to 30. We go down to 40, so it's actually being detected twice, and that's what my log messages are showing as well. So one last thing to finish before we can wrap this up. And the way I'm going to solve this is if I disable the, I'm going to disable the collisions on the rigid body, and I'm also going to check that these are disabled before I actually perform the processing of the collisions. So we'll say if the collisions are enabled, we're going to do all this jazz, and then to finish this in our reset method, we can actually enable this. So we go projectile rb.detect collisions equals true. And that should take care of that. This time, when we play this, now let's keep an eye on the health this time. We go from 100 to 70. Yes, much better. And then again, we should be able to detect it again. 40, very good. And then, boom. That should do it for today. I'm gonna go ahead, add some comments to this code. Thank you very much for watching. I'll see you next time. Cheers.